Hey, this is Mr. Mason, and what we're going to do in this tutorial is we are going to determine by what scale factor that a shape was dilated. And the information given says that the larger square was dilated to form the smaller square. And we have to determine by what scale factor was the larger square dilated. Now we can clearly see that we shrunk down this square. And whenever you shrink something down, the scale factor is going to be less than 1, which means we are dealing with some fractional amount, because the new shape is a fraction of what it once was. Now, with this example, the easiest strategy is to just determine the length of a pair of corresponding sides, and then write those lengths as a ratio, and that's going to be our scale factor. For example, this side right here has a length of 3, and its corresponding side has a length of 1. So we just take these two numbers and we form a ratio. And we're going to put the smaller number on top, which is 1, and the larger number on the bottom, which is 3. And the only reason that we did that is because we know that we're shrinking our shape down. And whenever you shrink something down, your scale factor is going to be less than 1. So we already figured out what the scale factor is. It is 1/3. Now let's say that you were dilating the smaller square to form the larger square. Then you would just take this scale factor and write its reciprocal. That would be 3/1, which is equal to 3. But that's not what we're doing with this problem right here, so 1/3 is our answer. Now, not only can you use corresponding side lengths to determine scale factor, you can also use corresponding points as well. For example, let's take this point right here. I'm going to take a look at its x value, which is 6. And let's take its corresponding point, which is right here, and its x value is 2. And because we know that the scale factor is going to be less than 1, I can take the smaller number, which is 2, and write that on the top. And I can take this 6 and write it on the bottom. And then we can take this and simplify, which would also give us 1/3. Or if I wish, I could take the same corresponding points and use the y values. The y value of this point is 1, and the y value of this point is 3. And that gives us a scale factor of 1/3 once again. Now, if you want to use corresponding points as a strategy, you have to remember that this will only work when the center of dilation is the origin, or 0, 0. All right, let's go ahead and do another example. All right, now the first thing we should do when determining scale factor is figure out if we are shrinking or stretching our shape. Well, this problem states that the smaller triangle was dilated to form the larger triangle, so we are stretching this smaller triangle to make the larger triangle. So I'm going to start by using corresponding side lengths. The length of this smaller triangle's base is 3, and the length of this larger triangle's base is 9. Now, because we are stretching this triangle out, our scale factor is going to be greater than 1. So I have to arrange the numbers 3 and 9 so we have a value that is greater than 1. And the only way to do that is by writing the 9 on the top and the 3 on the bottom. And 9/3, or 9 divided by 3, can be simplified to be 3, which is our scale factor. Now, let's say that we wanted to figure out the scale factor if we were shrinking down this triangle. We would just take the reciprocal of 3, which would be 1/3. Now remember, if you wish, you can also use corresponding points to determine the scale factor. For example, if we took this point right here and this point right here, which correspond, we can just use their x values. So we can use the number 2 here and the number 6 here. And we can write 6/2, which still gives us 3. Or we can take the corresponding y values. We have a y value of -3 here and -1 here. So if we write -3/-1, that also gives us +3. Remember, two negatives when divided form a positive. All right, let's go ahead and do another example. All right, this problem states that the larger rectangle was dilated to form the smaller rectangle, which means we are taking a larger object and shrinking it down, which means our scale factor is going to be less than 1. So really quick, we are going to find the length of corresponding sides. So the length of this side right here is 3, and the length of its corresponding side is 6. And we have to write the smaller number on top and the larger number on the bottom because we need a scale factor that is less than 1. And 3/6 can be simplified to be 1/2. And once again, we can use corresponding points to determine the scale factor. So let's just take this point here and this point here. If we do the x values, this x value is 1 and this x value is 2. So right away, we get the simplified scale factor, which is 1/2. And if we use the y values, we would get 3/6, which is also equivalent to 1/2. All right, let's go ahead and do another example. All right, so this time it says the smaller triangle, which is right here, was dilated to form the larger triangle, which means this smaller triangle is being stretched to form this triangle, meaning that the scale factor has to be greater than 1. So let's make our fraction bar and figure out what number we put on the top and what we put on the bottom. So I'm just going to use the length of this side, which is 1, and this corresponding side, which is 3. And we're going to have to write the 3 on the top and the 1 on the bottom, so we get a value that is greater than 1. So 3/1 can be simplified to get 3. And once again, we can use corresponding points if we want as well. So this point right here has an x value of 6, and its corresponding point, which is right here, has an x value of 2. And 6/2 can be simplified to make 3. All right, let's go ahead and do just one more example. All right, this problem states that the smaller triangle was dilated to form the larger triangle, which means we are stretching out our triangle, meaning our scale factor is going to be greater than 1. So once again, let's start with the length of corresponding sides. So I'm going to find the length of this side right here, which is 5, and the length of this side, which goes from -6 all the way to 4, is 10. So we must write 10 on the top and the 5 on the bottom, so we can produce a number that is greater than 1. And 10 divided by 5 is equal to 2. And if we decide to use corresponding points to solve, for example, we could take this point here and this point here. We would say that this x value is 2 and this x value is 4. So we would write 4 on the top and 2 on the bottom, which also gives us a scale factor of 2. And we may use the y values if we wish as well. The y value of this point is 4, and the y value of this point is 2. So we would still get 4/2, which is equivalent to 2. So that's how you can quickly determine the scale factor of a dilated object when the center of dilation is the origin.